In this video we're going to show the use of the fprintf command in MATLAB, which is a way of formatting numbers and text so that data can be shown more conveniently on the screen, and also that data can be saved to a file so that it can be stored for later use and can be read back in, potentially into a different program from the one that generated it. So I'm going to start in the MATLAB IDE. I'm going to define some value. I'm going to call this value x. I'm going to give it the value 3.1415926. And I'm going to use the fprintf command. Fprintf, I'm going to give it an open bracket so you can see what the syntax is for this command. You will see there's highlighted in blue, there is a thing called file ID, which I'm going to omit. So the first option of using the command I'm going to omit. I'm going to use a second option for the command here, which has a format specifier, which is a string, and then you can give it a set of variables. So we'll see what that looks like by doing the following. I'm going to put two quotation marks and give the value x, and then close off the command. And inside those quotation marks, I'm going to say the value of this variable is, and then I'm going to write %4.2f. So when I execute this command, you can see that x, the value of x, has been taken by the fprintf command and substituted in to where the %4.2f has been in the script, in the string. And something's missing. What's missing is there's no line break. So I have to press return in order to get back to a normal looking prompt. So I'd like to get around that. So let's go back to that previous command, and I can enter what's called an escape sequence by pressing the / key, okay, which isn't the /. Okay, we're going to use the / key, and we're going to type n so that this pair of characters here, \n, indicates that when the fprintf command encounters them, to put a new line. So now when we type that command, we get a new line break. So of course, if I want to, I can put several of these so that when I hit return, I get several line breaks. So what's happened here? This value x has been taken and substituted in at this point. We may ask ourselves, what is the meaning of those two numbers before and after the decimal point? Well, rather than reading the manual, we could always just play around and see what we can get. Let's try making this 6.2f. Aha, what's happened is it's put some spacing in before the number 3. Presumably, if we were to make this 6 decimal places, then it would display pi, or the value of x, to a larger precision. So this is a little bit like the format command that we saw before, except we have control over how many digits this number is displayed over. So if we really wanted to have fine control over how many characters were displayed in the string, we can do it. Let's change something. Let's get rid of those extraneous new line commands, and instead of writing %6.6f, I'm going to write %d. Aha! %d displays it in decimal format. What happens if I define x equals 3 instead of 3.1415, etc.? If I were to run this again, then the value of this variable is 3. So if x is an integer, %d is a convenient way of displaying the integer value at that point in the string. What happens if we have several variables? Let's define a variable y is equal to 5.28, and we'll define x as equal to 3.24, and we'll say that z equals x plus y. We can display this using the fprintf command by typing the following: fprintf, and we'll say %4.2f plus %4.2f equals 4.2 f and close that quotation mark, and then put in x, y, z. What happens there? Oh, I forgot to put fprintf at the start. There we go. Aha! Oh, and I also forgot to put in the \n at the end. There we go. So when I run this command, you can see that it writes a string which tells me the values of the variables. So this is a way of using fprintf to display in a readable form what's happening inside my code. So this is a bit more flexible than what we can achieve using the disp command. Now, what happens if we define an array? We'll define an array x equals, and we'll give it a set of values. Let's say 1 colon 10. So x is now an array of 10 values, and let's type fprintf the value of x is, and I'll put a \n to remember to do that this time, and oh, I should actually put in that I want %4.2f in there. I'm going to type x, and then I'll hit return. So this is a single line command. When I press return, I get 10 lines of output. So what's happening? This text here is constant, but because x has multiple values, x has been substituted, the values of the values in the array x have been substituted one at a time into this slot, and fprintf has printed out the result of each of those values, and of course has also formatted them using the number of decimal places which we have provided, and the number of characters as well. So this is a very useful way of outputting large amounts of data. Let's see that in action using a script. So I'm going to now create a script, and I'm going to call this script, remembering to put a few line breaks in, I'm going to call this script making a data file, and I'm going to create some x values. I'm going to create some x values from 1 to 100, 1 to 100, and I'm going to create some y values which are equal to sine of the x values, where I'm going to multiply by 180, multiply by pi divided by 180, so that I'm converting the number x so that it's from degrees into radians. I think I've done that right. Yes, that's right. Okay, and of course when I do this, I want to plot x comma y, and I'll make these, in this case, red pluses, and I'll save that file, and I'll call that make data, and save that. I will now run it, and it will create a plot. There we go. So that's the first part of a sine curve. Now, what I'm going to do now is I'm going to shut that window, and I'm going to replace the plot command, and instead I'm going to save the data. How can I save the data? Well, I can use the fopen command. So I'll type fopen, and I'll hit open brackets so that we can see, aha, I want to open a file name. It's not quite enough detail there, so I'm going to use the help command. I'll do help fopen, and you can see, if I scroll to the top, that I want to open a file. There we go. I want to open a file for writing. Okay, so let's have a look at, is there an example? Here we are. File name, permission, machine format, encoding. So I think we just want to have FID equals fopen of a file name for writing. Okay. So let's do that. We'll say FID equals file open my data.txt, and I want to open it for writing with a W. And when I do that, I can now do fprintf, and I'm going to say x value, percent 4.2 f, and put a \n in, and type x there. And I want to put the FID at the beginning. There we are. And then I want to do f close. I think with f close, if I just hit an open bracket, it just says yes, I need to give it the FID. So the FID is a variable which is like a telephone number for the file. The FID has been allocated when I open the file for writing, and then the fprint command, if it uses this telephone number, as it were, it can send these x values to the file, and then the file is then closed, because we should always hang up the telephone so we don't leave an open line. We can do that with the fclose command. Does it work? Let's try running it. Something seems to have been created. So you can see that I've created some x values on the right, I've created some y values, and it so happens that the FID that's been allocated was the value 3. That doesn't really matter, it just needs to be the same number used consistently whenever I'm writing to one particular file. And on the left here you can see that mydata.txt has been created. Well, let's double click on it and see what it looks like. So mydata.txt is taking a little while to open. What's it doing? Rather slow. There it is. So you can see that mydata.txt, that single fprintf command, has written out all the x values. Okay, so that's not yet very useful. Let's try and write on the left-hand side an x value, and on the right-hand side a y value. So let's do that. I'm going to write down x, y, and instead of having just one value, I'm going to delete that, and I'm going to put in between those a tab indicator, and I'm going to type percent 4.2f, and this is going to take the x values and all the y values, and it's going to print them out into the file. Actually, this won't quite work yet. We'll see how in a moment. Let's run the file again. And something's happened. Let's double click to see what has been created. So you can see that it's not quite worked out as we wanted yet. What has happened is that because we put x first in that command, in fprintf command, it's taken all the values of f and taken them one by one and put them into the slots which are available. And when it's got to 100, it then moves over and starts on the y values. It's gone down. So actually this isn't what we wanted, which was to have a column of x values on the left and a column of y values on the right. So how can we fix this? Well, one thing we could do is we could put brackets around the xy values and then put a transpose on it. We can swap the rows and the columns. Just to see if that's working, let's grab that piece of code, copy it, go to the command window and see if it is actually correct. We'll have to see. I'm not quite sure if it's worked yet. Doesn't look quite right yet. Let's type some other format. If we type size of that value, let's see what that 200 times 1, so that hasn't quite worked yet. How are we going to swap those round? Well, let's see. Let's just say to ourselves, well, we can't quite figure it out at the moment. It should be possible to rearrange these values so that they appear in the right order. So that the first value of x is then followed by the first value of y, and so on. So I'm going to leave that as an exercise for you to figure out that it is possible to do this all with a single command. But I'm going to show you another way that you can use if you can't figure it out. And of course what we can do is we can simply put a for loop around the fprintf command. So let's do that. So I'm going to say for I equals 1 to the length of x, and put an end statement at the end, indent the fprintf command, and then it's quite easy because all I have to do is say xi and then yi. So for each value of I will pick out the ith value of x and the ith value of y. Of course I have to assume that there are the same number of y values as there are x values, but that's implicit in our definition of y further up the code. So let's try that and see if that works. So we'll run run the program, and we'll double click, and hey presto, here we are. So we have 1 degree and the sine of 1 degree and so on. Scroll down to the bottom. So that's a way of getting around things if you can't get the ordering of your x and y values as you'd like them to be. You simply put a for loop around them. Okay, so what? Well, let's create another file that will read the data. So I'm going to create a new script. What I'll do before I start, I will grab this text and I'll create a new script, and I'm going to paste this text into the new script, and rather than writing the file, I'm going to read the file. But of course I can't use fprintf because that's for writing. I need to use the other command, which is fscanf. So I'll type help fscanf, and let's see what that does. fscanf reads characters using the encoding scheme, blah blah blah. Let's go to the top. Here we are. Reads and converts data from a text file into an array A in column order. So let's just copy that, and we want to have the correct format. So it says format is a string containing ordinary characters. Well, let's just try that. So we'll say paste that. Oops, forgot the bracket there, and we need to put FID here. And is there? We have to ask ourselves, does this format have to be in quotation marks or not? There's an example down here which is quite useful. And let's have a look. We'll say quote %f quote. And of course, so far we're not quite sure what this thing here is doing, but let's try it out and see what happens. So it's going to create an array A. So I'll save this file as read data.n. and I'm going to run it, see if it works. Oh, something's happened. It's created an array here, A. What does A look like? A is, so you can see that the array has come out, so the data has been taken out from the file, but it's not yet in the right format. It's all just in one long list. So perhaps that formatting option, which was given at the end of the help file, might help us. So we'll have a look at help fscanf. So you can see that we can try out commands and we can massage them and we can gradually adapt them until they give us the result we want. I think if we type 2,inf, yes, you see file count.dat contains 3 columns of integers. Well, we have 2 columns, so presumably this 3 must be turned into a 2. So we'll copy that text and we'll put it into the top here, and we'll turn that into a 2, and we'll try again. So we'll run it again. I'm going to change the name A and we'll call it my array, and we'll call this my count. And just to make sure that we know that nothing has been left over from a previous run, I'm going to type clear all at the top of the file, at the top of the script. I'm going to show you what that does in the command window. If I do clear all, it removes all the variables from the workspace on the right. So if it's already been cleared, of course, it'll still remove the variables again inside the script. So I run the script, there we are, and it's created an array called myArray. And now you can see that it's a 2 times 100 array. So we'll do my array. What does it look like? Well, it definitely has 2 columns. Let's have a look what my array 1, colon looks like. So the first row contains all the x values, and the second row contains all the y values. So maybe what we want to do is do the transpose of my array. So my array equals my array transpose. In fact, we can put that, actually, probably better to put that below the fclose ID. Put that there. Save it again, and we'll run it again. There we go. And now if we type my array 1, colon, it should give us a pair of values, the first row in our original data file. Now, of course, if we want to plot this data, we probably want to keep it in the original way round, which was with the first row, the first element of the array being the x value. So we'll say x from file equals my array 1, colon, and y from file equals my array 2, colon, and then I can now plot. I'll do x from, hit tab, x from file, and then y from file, didn't put, no comma, y from file, and put some red pluses again, and put a quotation mark there, and save it and run it. And you can see that I've read in some values from a file which I've previously written using the other script, and I have created a plot. Let's show that on the right there. So that shows how to create data using the make data script on the left here. What the data file looks like once I've correctly formatted it, and what a script looks like that can read that data back in and plot it.